In this video, we're going to talk about triangle sum properties. So first off, we're going to talk about the different types of triangles we are going to be classifying by the sides and by the angles. So if you look at the three pictures right here, this is a scalene triangle because there's no sides that are congruent to each other. All three sides are different lengths. An isosceles triangle means that two sides are exactly the same, so you have at least two congruent sides. An equilateral triangle means that all three sides are congruent to each other, so it would all be the same exact measure. So that's when we classify by the sides, we have to know how many sides are congruent to then classify it by the name. So next is classifying by the angles. So if you look at the degrees of your different angles in your triangle, if you have a right angle, so a 90 degrees, then you have a right triangle. There can only be one of those angles in there. And then if there's one angle that is over 90 degrees and there's only a possibility of having one, then it is an obtuse triangle. If all three angles are less than 90 degrees, then it's called an acute triangle. So more specifically of an acute triangle, if all three angles are exactly the same size, then it is an equilateral triangle. So an example of an obtuse isosceles triangle is we need to draw a triangle with two sides that are congruent, and the angle, one of the angles has to be over 100 or over 90 degrees, sorry. This is only going to happen if there is only one angle that's over 90 degrees, so with our 100 degrees there in the center, as you can see. And the only way that it's going to be isosceles is if the two sides that are next to it are the congruent sides. And that's something we're going to learn later, but these other angles then would be identical as well because those two sides are the same. So next is an acute scalene triangle, so all three sides have to be different, and the three angles also have to be different. So that one is a little quicker to draw, since we can pretty much just draw it like so, and all three sides are the different lengths, and all three angles are going to be different sizes as well. This is a pretty typical question, and you'll see a few of these on the test as well, is that they'll give you a picture on a graph or just the coordinates of your triangle, and you have to classify it. So this time we're going to classify by the sides, so that means that we need to know what each of these side lengths are going to be on all three of them. So the way to do that is we need to find the distance of each of those sides. So remember, there's two different ways we can do the distance. We can use Pythagorean theorem, or we could use the distance formula. Most of you before had chosen the Pythagorean theorem, so that's the way that I'm going to do it as well. So in the first one, in the first side over here, between point P and O, I can see that in my picture there's one across and two high, so I'm going to do my a squared plus b squared equals my c squared, so the distance of that. You can see the rest of my work that once I square it, I get 1 and a 4. I add them together to get my 5. I take the square root of it to find my c, which gives me 2.236. So that's the distance between P and O. So next I'm going to do between O and Q, which gives me 36 and 9. So if you look, you get a 45 equals your c squared. So when I counted, I got my 6 and 3, so my 9 and 36 when I square them. So square root of 45 gives me the 6.708. So next we're going to do distance from P to Q and find the distance there to see if it matches one of these other ones, so that I can tell us that's either isosceles or if it's just going to be scalene. The distance from P to Q, if you can see, is from 1 up and down. The run is 7. So if I square 1 and 7 together, I can take the square root of that, and that'll give me the distance of PQ. When I square my 1, I get a 1. When I square 7, I get 49. So when I add them together to get 50, I can take the square root of that, and that'll give me my C. When I take the square root of 50, I end up with 7.071. As you can see, we're going to have a scalene triangle, since we can see that all three side lengths are different sizes. This is a question that's going to be just like the previous one. So you have three vertices you have to graph, and then you're going to classify it by the sides. Also, I want you to add on if you can determine if it is a right triangle based on the picture. So remember, you can push play after you push pause, once you've worked out your question. Alright, so the distance from B to C is probably the easiest one, and if you count that, there's 6 spaces between it. For the next side, BA, you get 3 and 3 for the two sides of that right triangle to make up that side in our triangle, in our black triangle. So you get 3 squared plus 3 squared is 18. This means when we take the square root of 18, we get 4.243. So next we're going to do the same thing for CA. For CA, we also get 3 and 3 for the two sides of the triangle that make up that side in the black triangle. So we get 18 again and 4.243 for the length of that side. Since we can obviously see that two sides in our triangle will be congruent, we have an isosceles triangle. To check to see if it is a right triangle, we need to take our two sides, and usually it's the congruent sides, or just our two smallest sides, and square them and see if it works with our a squared plus b squared equals c squared. And you can see where I got my numbers from. So I take my two smaller sides and I square them, and if you notice I left it with the square root. That was because after I square it, they actually cancel each other out, so we get 18 plus 18. The right side of my equation then, I end up with a 36. So the left side, I combine my like terms together, my 18 and my 18, and I actually get 36 as well. Because they end up being the same exact number on both sides, this tells us that it is a right triangle. If they were not equal, so if a squared plus b squared did not equal the c squared, then that means that it is not a right triangle. So next, we are talking about interior and exterior angles. So I need you to copy down your picture and show maybe color coding if you see in my picture on this left, the interior are those three interior angles in my triangle. The exterior ones then are on the outside parts that make up the linear pair with that interior angle. So we got this one, we've got 4 over here in the blue for our exterior, and then 3 in the interior. So go ahead and copy those pictures down. These next two are pretty much just theorems that we're going to be using pretty often. So in this first one, if we have all of our interior angles, the sum of those measures of the interior angles of a triangle are supplementary, so that they add up to be 180 degrees. So the sum is 180 degrees, and you can see in this little picture right here. So the next one, all the exterior angles, if we take the exterior angle, this angle 1 in my picture over here, the measure of that exterior angle of your triangle is equal to the sum of the measures of the two non-adjacent interior angles. In my picture, the non-adjacent ones will be not this angle right here, but inside, so it will be these other two. So my angles A and my angle B are my interior angles. So if I set my angle 1 equal to the angle A plus the angle B, that they are equal to each other. So I can use this setup to solve for a variable. We're going to use this setup when we solve for x in this triangle. So if we set the 2x minus 5, that's our exterior angle, equal to the other two interior angles inside added together, then we can solve for x. So you can see in my picture, I've got 2x minus 5 equals x plus 70. So go ahead and push pause, and you can work out for x. And then once you solve for x, then remember you need to read the directions again. So we have to plug it back in to find the angle JKM, and that's this exterior angle you're going to have to put it back into. So go ahead and push pause. Alright, so when you are solving, this is what some of your steps should look like. Next, we have to add 5 to both sides. And I get that x equals 75. So remember, we need to put that back into up here. So we're taking 2 times 75 minus 5. And 2 times 75 gives us a 150. 150 minus 5 gives us 145 degrees. For the corollary to the triangle sum theorem, remember that all the interior angles add up to be 180 degrees. So part of that is if it's specifically a right triangle. If you think about that, in a right triangle, we know that one of our angles is 90. So if we take 90 away from that 180 that they all need to add up to be, that means that the remaining two angles need to add up to be 90 degrees as well. So the other half of it. And that's what this says. So it says the acute angles of a right triangle are that they are complementary or 90 degrees. So the biggest thing is that we can add up the remaining two angles have to be 90 degrees because the 90 degrees, because it's a right triangle, is already taken up out of our 180. In this picture, you can see that there is a staircase and it forms a right triangle. So that means this angle right over here is 90 degrees. The measure of one acute angle is 3 times the measure of the other. So if we make this angle the x, that means that the other one is going to be a 3x. So we know that the three angles add up to be 180 degrees. So we're going to set up x plus 3x plus 90 equals 180. And then we can use this to solve for the x. So first we can combine our like terms together. So we get 4x. We can subtract this 90 from the other side. So we end up getting 4x equals 90. And then we can divide by 4, and we're going to end up with 22.5 22.5. When we take this measurement and put it back into our triangle, the two acute angles will be 22.5. And when we multiply that by 3 for the 3x, we get 67.5 degrees. For this next one, I would like you to try to set it up. So remember that this exterior angle, that's equal to the other two interior angles added together. So go ahead and set up your equation and solve for x. When you're ready to check your answer, you may push play again. This is what your equation should look like. And then when you are solving for x, if you move your 3x to the left side, this is what we will end up with. If you add your 10 and then divide by 2, you end up with x equals 25. If you reread the directions again, it's asking you to find the measure of angle 1, so we could do a couple different things. I am thinking of putting the 25 into this exterior angle, and then I know that these two angles here make up a linear pair, so once I know the exterior angle, I can subtract that from 180 then to find my angle 1. So let's go ahead and put the 25 back into the x. So 5 times 25 minus 10 gives me 115 degrees for this exterior angle. So then if I take 180 minus that, I get 65 degrees. So that's what the measure of angle 1 is equal to. These two questions are ones also I would like you to try of the same ones I showed earlier, just to make sure you're on the right track. So go ahead and draw your picture, label them, and find your x. Also, you're going to find the measure of each of those interior angles in the first picture and the acute angles in the second picture. Here's a picture I drew, so I'm going to take x plus 2x plus 3x equals 180. When I combine my like terms together with my x's, I get 6x equals 180. To solve for x, I'm dividing by 6 on both sides, so I end up with x equals 30. Because I know that x equals 30, I know that my angle A, since that's just the x itself, is 30 degrees. Next, I know that my angle B is 2 times the x, so 2 times 30, so I get 60 degrees. And lastly, I know that my angle C is 3 times the x, so 3 times 30, which gives me 90 degrees. So for the next one, the measures of the acute angles of my right triangle, I know that really all three of the angles added up together give me 180 degrees, but since this is already 90 degrees, then the remaining two angles should equal 90 degrees when I add them together. So my equation will be 2x plus x minus 6 equals 90. I need to combine my like terms, so I get a 3x minus 6 equals 90. I need to move my 6 to the other side by adding 6 to both sides, which I get 96, and then I divide everything by 3, and I get a 32 for my x. I need to take this 32 and plug it back into both of the acute angles. So this gives me, for one of them, gives me 64 degrees, and for the other one, that's 32 minus 6, I get 26 degrees.